Hello friends, now that we are aware of the what is numerical integration and also we have seen some formulas of numerical integration, let us solve some examples on this. So example is evaluate integration from 0 to 1 of 1 upon 1 plus x square dx by using Simpson's one-third rule, taking 4 equal strips and hence deduce an approximate value of pi. Now we need to evaluate this integral first by applying Simpson's one-third rule. Now here, as we have seen already, these are the limits of the interval integration are 0 to 1. So that means the first value of x that we are going to take will be 0. That is a is 0 implies our x naught value is 0. Now upper limit, let us denote it by b. So b is 1 and the function given the integrand, it is 1 upon 1 plus x square. Let us denote it by y. Now here we are going to apply one-third rule and then we should know that n should be a multiple of 2. And further it is also mentioned that we have to divide the interval into 4 equal strips. That means n should be taken as 4. If at all it is not mentioned, then because we are applying one-third rule, we should take either n equal to 4 or n equal to 6. As n increases, accuracy increases. So now, since it is given 4, let us consider n equal to 4 now. H is b equal to b minus a by n. We get h as 1 by 4. Now, a equal to x naught, that is 0. Then x1 is x naught plus h. So we'll get x naught 0 plus h, that is 1 by 4. We get 1 by 4. x2 is x1 plus h, 1 by 4 plus 1 by 4. It is 2 by 4, or we can put it as 1 by 2. x3 is x2 plus h. So 1 by 2 plus 1 by 4. It is 3 by 4. Next x4, it is x3 plus h. 3 by 4 plus 1 by 4. We'll have to get, we'll get 4 by 4, that is 1. Now, how many values you are going to take? It is mentioned here. 4 strips means the set of values we get is 5. Or you can even see that we should stop taking these values of x once we get the upper limit of our integral. So the upper limit of our integral is 1 here. So once we get 1, we have to stop. And since n is 4, we have got 5 values of x. Now correspondingly, let us find the values of y for these values of x and put them in a table. X value, x naught 0, x1 is 1 by 4, x2 is 1 by 2, x3 is 3 by 4, x4 is 1. Now correspondingly y is 1 upon 1 plus x square. Now substitute the values or write this equation in your calculator and go on giving these values of x. Nothing wrong if at all you keep the values in decimals. It is according to your convenient. So 1 upon 1 plus x square is the function. Put x equal to 0, we get 1. Putting x is equal to 1 by 4 here, we get 1 plus 1 by 4 whole square. So simplification will give us 16 by 17. So thus substitute all the values of x and calculate y at these values of x now. Now we go for Simpson's one-third rule, which is given by integration from a to b y dx. It is h by 3 y naught plus, in the formula we have written yn. Now since we have got only up to y4, the last value we have to write here is y4. Instead of yn, we'll write here y4 plus 4 times, it is odd suffixes of y. So y1 and y3 are the only odd suffixes of y we have in this table. So I'll write y1 plus y3 plus 2 times y2. So 2 times it is the even suffixes y2. Don't take y4 because it is already taken here. So we will not repeat any of the value in the formula. Not only this, nowhere will be repeating any of our y terms. So see that, thinking that y2 and y4 is also having the even suffix, don't write y2 plus y4. Here y4 is already included, so we'll not take y4 here. Now substitute the corresponding values from this table in this formula. Simplification will give us that the value of integration from 0 to 1, 1 upon 1 plus x square dx is 0.7854. That is the evaluation of integral. Now further it is asked, find the approximate value of pi. So whenever you are asked with any value, go for integrating your LHS. Integration of 1 upon 1 plus x square, it is tan inverse x. Limits are from 0 to 1. Already we have got the value. Keep this answer as it is. Now tan inverse 1 upper limit, when you put, we get tan inverse 1. Value of tan inverse 1 is pi by 4. Tan inverse 0 is 0. So we have pi by 4 is 0.7854. So pi becomes 4 times this value. That means we get pi equal to 3.1416. So that is how we obtain the approximate value of pi using the result whatever we have got. Hence deduce it is. So whatever the result we have got, using that we need to find the approximate value of pi. Let us move on to one more example. The velocity v given in kilometers per minute of a moped which starts from rest is given at fixed intervals of time t minutes as follows. So it is given a list of values of t and the corresponding velocity at that time here. Now estimate the approximate distance covered in 20 minutes. In 20 minutes, how much distance will be covered, that we need to calculate. Now here see that if you count these values, then there are 10. I hope 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means n plus 1 is 10. So don't take that, because see that here, read the question correctly. The velocity of a moped which starts from rest is given, but that value that starts from rest means initially time will be equal to 0 and velocity will be also equal to 0. That value is not given. We need to take that because it is given it starts from rest. We'll put the table once again and write the value beginning with t equal to 0. Continue with the next values up to 20, and correspondingly at t equal to 0 velocity will be also 0. So take this one set of values. Even though it is 0, don't neglect it. This changes your uh, v1 v2 values here, so we need to write them. Now write the other values correspondingly. Better it is to note them down like this: v naught, v1, v2, or if you are not convenient, you can write y1, y naught, y1, y2 like that also, and denote instead of t you can write here x also. Now we need to find the distance. Now we know that distance covered, it is integration of ds by dt, or it is integration of v. Now it is given the time taken is from 0 to 20 minutes. So integration should be done between 0 to 20 of the velocity. So integration of velocity will give us the distance covered. Now here we can see that now we have got 11 set of values. That implies n plus 1 is 11 and hence n will be equal to 10. Now since n equal to 10, it's an even number or a multiple of 2 here, then necessarily we have to apply Simpson's 1/3 rule. They have not mentioned which rule we need to apply. So because we have got n as even, then we need to apply Simpson's 1/3 rule. Now you can even see if you don't take this value, then you will count n plus 1 as 10, then n becomes 9 and totally it becomes wrong. You'll be any rule you apply, answer should be same, but the value of n changes. So see that you'll take the set of values, then count the set of values here. The n plus 1 is 11, n becomes 10. Now take h is equal to b minus a by n. The value we get is 2. B the upper limit, A is the lower limit. So B is the upper limit, A is the lower limit divided by N. N you can see it is 10. So we have H is equal to 2. Even it's not necessary to calculate the H because the table values are given, and we know that the values of this x or t, they are equally spaced, so we can see that h will be equal to 2 here, because the distance between or the difference between any two values of t, it's always 2. So directly also you can write h is equal to 2. Now let us apply Simpson's one-third rule, because n is a multiple of 2. Now integration from a to b v dt, it is equal to h by 3 y naught plus yn will write. So instead of that, v naught plus last value of v, that is v10, plus 4 times odd suffixes of v. How many we have got? We list all them here. v1 plus v3 plus v5 plus v7 plus v9. Then plus 2 times even suffixes. So don't take v naught, which is already taken here. v2, v4, v6, v8. Again skip the last value. No value should be repeated, so I'll take only up till v8. Now substitute all the values of v, then simplify. The distance covered will get it as 309.33 kilometers in 20 minutes. So that is how we apply Simpson's one-third rule to evaluate the numerical integration.